We're going to be taking a further look at some of the new features in C# 10 this time, and specifically into a number of changes around the area of structs and also records. Now, records were introduced in C# 9, and I did a video on that a little while ago, and I'll put up a link, and basically I'm building on the same example that we had then. So what I've got here is this setup where we have a point C, which is a class, and it's just a 3D point with X, Y, and Z. We've got a point S, which is a struct, which is, again, same thing, but as a struct. And then what we introduced with C# 9 was this record. So there we've got this point record where we've used this simple way of declaring the whole record just as X, Y, and Z. And if you remember, that generates lots and lots of things for us in terms of double equals operators, not equals operators, toString, and some other things as well. And then we've got an example of inheritance with a record, so we've got this 4D point derived from the 3D point. Now, the first really simple thing we're going to look at is something that's caught me out again and again over the whole history of C#, and that's the fact that when you have a struct, a value type, traditionally you're not allowed to give it a default constructor. So if we just check in the project file, at the moment I'm on version 9 of the language, so I'm going to switch between 9 and 10 to show the differences and highlight them. And although on a struct, if I were to put in a constructor that actually took the values, so if we had double X, double Y, and double Z, and then said X equals X, Y equals Y, Z equals Z, lots of nice features of Visual Studio filling that in for us, then it's perfectly happy with that. But what we're not allowed to do is have a constructor that takes no parameters, a default constructor as it's sometimes called. And you can see it's just saying we can't do that, but it is suggesting we upgrade to version 10. And the reason for that is that the original idea was that the struct's default constructor should just set everything to its default value. So doubles would be 0, strings would be null, that sort of thing. But you're allowed to do that now. So if we upgrade this to version 10, and then go back in here, I'll just give that a quick build. It's still complaining, but now it's simply complaining that I haven't done the initialization. So now I could say X equals 1, Y equals 1, Z equals 1, doesn't matter what they are, but we can give it a non-zero default value. So that's something that's available now in C# 10. And also it's worth pointing out, because it's very similar to that, we can also put in an initial value in line like this. So I could do something like that. And again, that wouldn't have been valid if we'd got this in C# version 9. So that would be an error in version 9, as you can see, and not allowed to initialize, but valid in version 10. So that's quite a nice change that we've got in there. But that's really just a couple of small improvements on the struct we already had. What the big change is, we have the idea of the record struct, because records were introduced in C# 9, but a record, as we can see here, our point R, is a reference type. So it lives on the heap with a reference to it wherever the variable may be stored. But it gives you all these things for free, as I mentioned, like the double equals and that sort of thing. And so those things don't come for free with a standard struct. But now we can do this. We can say public and then record struct, and then we'll call this point rs for record struct, and then we can do the same sort of thing. And in fact, I'll just copy that straight off there. So I can put that in there. And again, you can see it's not happy with it, but if we go to version 10, then now we have created, in many ways, almost exactly the same thing as we had with the record class, but it's a value type, so it's going to live on the stack. In fact, you can see we've got now a slight asymmetry in that when we say public record, that is a record class, a reference type. So also, very minor thing that's been added is you can actually say record class. So if you just say record on its own, it is a record class, a reference type, but for symmetry, you can also put class in there. And I think that's a bit clearer. That's probably what I'd do going forward, just so it's absolutely clear what's going on. But now we have this record struct, and let's actually compare that with the original struct. And the easiest way to do that comparison is to use ILDSM, the Intermediate Language Disassembler. So let's just run that up. And then let's dive in here and find the DLL. And then if we look inside the namespace records, we can see there we've got the record struct, the point rs, and there we've got the simple struct, just the point s. And if we open both of those up, then we can see the different things that have been generated. So down there, we've got the struct, and it's just got properties for x, y, and z, and the backing fields and that sort of thing. But then we can see rather more that we have in the record struct. So we can see, for example, that it implements the iEquatable interface, just the same as a record class did. We can see it's got a deconstruct, just the same as a record class did. I'm not going to go into all of these in detail. Have a look at that earlier video and you'll see what those are all about. You can see it's got an equals, but it's also got an operator equality, the double equals, operator inequality, the not equals. So lots more things that have been provided for us. And we can see all those. If we go to the program here, I could just take what we've got there, and then we'll put in point rs, change the variable name, and you can see we've got our record structs. And just to highlight some of those things I mentioned, we've got the double equals and the not equals. So if I just do something like a console write line, rs1 double equals rs2, that's all happy. Or if I did a not equals, that's going to be happy as well. But if I try to do the same sort of thing on our struct, so just put s1 double equals s2, then you can see it doesn't do that because it doesn't have that double equals operator. We do on a struct have an equals method that's been written for us in the correct way. So if we do that, we can see that when we run that, we're getting true, false, and false, because s1 doesn't equal s2. And if I change that so it does equal, then we're getting true, false, and true. So the equals does work, but it doesn't have the nice convenience that we have the double equals and the not equals. Also, as I mentioned, this idea of iEquatable. So if I do an iEquatable for point rs and just say eq equals, take the first one, rs1, you can see that's perfectly happy. Whereas if I tried to do that for just a point s and make that s1, then again you can see it doesn't support iEquatable. So that's what we've got there. Another thing that we get for free, if I just do a write line of rs1 and then a write line of s1, so we're looking at the toString basically. Remember, those both just implicitly call toString. Then we can see that we've just got the built-in object toString that gives you the fully qualified name of the namespace when it comes to a struct, but when it comes to a record struct, we've got a simple but useful toString that tells us what the information is. Now, one slight difference though that we've got between the record struct and the record class, apart from the obvious one that one is a reference type, one's a value type, is that by default, a record struct is not actually immutable. So remember, one of the key things we know about a record class is if I try to say r1.x equals 27, then that's not allowed. But if I try that on the record struct, we can see it is allowed. So by default, they are not immutable. But that's something we can fix pretty easily because we can also have a read-only record struct. And that will simply change it to be immutable. So it's always the case with the record class. Actually, you could previously have put read-only on an ordinary struct. That's been around for quite a while, and that would simply then force you, when you're writing the code for yourself, you wouldn't be allowed, for example, to have a public set on there because we've said it's read-only. So read-only is not an entirely new feature for structs, but we can now put it on the record struct, and that means in the program now, when we say rs1.x and then whatever we want to put in there. Now we're getting the error saying that that is init only. So you've got a choice that you can make there. Now, one of the uses that this could well be put to is to actually discourage developers from overusing tuples. Now, tuples are value types. We looked at them in an earlier video, and there's a reference up there to that. But the problem with those can be is they are anonymous, and so it can be a bit unclear in the code what's going on. So, for example, if I were to do something like this, I could say var, call this point, equals, and then simply say x colon 1.0, y colon 1.0, z colon 1.0. Just put all of those in there. So you can see that it's giving us a warning because we're not using that, but you can see we've got the tuple there of double x, double y, double z. But the problem with that is it's not a named type, and if ever I want to declare the type for it, I would have to be doing something like double x, double y, double z. And obviously I can use var in that case, but if this was a parameter or a member variable, then you wouldn't be able to do it that way. So what we can do with a struct now is pretty simple, because if I just go back having the var, all I need to do is put in my new point rs. So that's the only change to the code. Everything else works the same, but now we have this as the correct type. And so that's just much more convenient because it gives us a named type rather than always having to repeat ourselves with double x, double y, double z. Another slight change has been added that simply makes things more consistent across the different types is we can now have the with expression with not only a record struct, as you might expect, but also with a traditional struct. So the thing we can do with, I can say var, and then let's call this rs3 equals rs2 with, and then we can just have z equals 200, say. And so, as we saw last time, that creates rs3 as a copy of rs2, except that we have changed the value of z to 200. But we can also do that with plain old struct. So I can say var s3 for our struct equals s2 with, and just do the same thing, z equals 200. Now if again we switch back to version 9, then we can see that quite a lot of things break, obviously, but particularly that one. So you can't have with even on structs in C#9, but you can in C#10. And that's also something you can now do with anonymous types and with tuples. So if I were to say var anon equals, and then we'll just have new, and again, same sort of thing, x equals 1, y equals 2, z equals 3. So that's our anonymous type. If I then said var anon2 equals anon with, and then again, z equals 200, you can see it doesn't like that, but if we switch back to version 10, then it's happy to do that on an anonymous type, and I won't show it, but the same would go if we were dealing with a tuple. You can do a with there as well. Couple of final small features. One is something I never really noticed you couldn't do, but it does fix a slight problem. And that is on our record classes, you can now declare your toString as sealed. Can't do it on record struct because you don't have inheritance with structs anyway, so it's only going to apply to record classes. But let me show you the small issue that this fixes. Here we've got our record class, which is the base class, and then remember we've derived that into this point4d. Now suppose we had provided our own toString on the base class, which is something you're allowed to do, and so all we're going to do here is something silly. This is the base class. So if we just create one of each, so we'll create a 3D point. So that's our point R, and just give it some values. And then we'll have our 4D point. And then if we say console write of P3D and console write of P4D and run that, then we can see that the base class has the overridden one I'd done, this is the base class, but then the derived class has the auto-generated toString that you get for free when you have a record. And that's a little bit irritating because if we've changed the behavior in the base class, we probably don't want to then have the automatically generated one in the derived class. And so that's why it's useful to seal it, because what I can now do is in the base class, as well as overriding that, I can say that that is sealed. And now we can see that the derived class doesn't do the generation, it just has the same one as the base class. Which here may not make a huge amount of sense, but I can imagine situations where you're getting irritated by having that generated toString when you thought you'd overridden it in the base class. And then the one final thing we've got, again, pretty minor thing, but it makes the way you program more consistent, easier to use, and that's to do with deconstruction. So you remember that when we're dealing with records, be they classes or structs, or indeed with ordinary classes and structs, we can write a deconstructor. And the way you might use that would be something like this. We could have written var x, var y, var z, and then say equals, and let's just use our P3D there, to deconstruct the point back into its x and y and z. And then we could print off each of those. So let's just put values. And so now that x, y, and z are just local values, so we could just use them in any way here, just printing them off. And so we can see that we get 1, 2, and 3 coming out. Another way you could do that is actually you could declare them in a more traditional way. So I could say here double x, double y, double z, and now I don't have to declare them within the deconstruction because I've declared them before. So that will work in exactly the same way, and depending on circumstances you might want to do one or the other. And that was all available. Let's just prove it. Switch back to C#9 and it'll still work in the same way. Obviously still getting a few errors for the other features, but that one is okay. But the problem you had in C#9 was you couldn't mix those two approaches. So I could have all of them declared in advance or all of them declared in the tuple, but if I wanted to mix those together, so suppose I didn't have y in there, I wanted it in there, you can see it's now complaining, mixed declarations in a deconstruction, why don't you upgrade to version 10? So let's follow its advice, take that back to 10, and now we can see it's happy to mix those together. So a few of those are really pretty tiny improvements. They're not things I ever stumbled over. I never had that problem with mixing together where the declarations go. I never had the problem with the sealed toString wanting to seal it, but you can imagine how they're just slight inconsistencies that made the language a bit rough at the edges that have been smoothed over. Having the record struct, and particularly the read-only record struct, are going to be quite useful features, I think, because they do a lot of code generation and make it easier to use a struct without having to write the toString and other things for yourself. And also things like that default constructor or initialization on a struct, as I mentioned, that's something that's occasionally caught me out, so that's a useful thing to have. So that was another area of new features in C#10. Hope you enjoyed it. Do click like, do subscribe, and come back soon for more new features.